Okay, so trapezoids and kites. Here's the definition of a trapezoid. It is a quadrilateral, which means it has how many sides? 4. It's a quadrilateral with only one pair of parallel sides. It only has one pair of parallel sides. And that's usually the top and the bottom. So here are the parts of a trapezoid. This is a trapezoid we're talking about. We're not on the kites yet. These are the one pair of parallel sides. And then this is called a base, because a base is where you have your base. It's what lays on the bottom. So you have your base and your base. And then these two sides are called legs. That's a leg, and this is a leg. Okay, now, these same sides. So if this is X and this is Y, only your consecutive angles add up to be 180. So X plus Y equals 180 only when they're on the same side. So what did I write? Only on same side. So that X plus Y equals 180, and these two right here also have to equal 180. So that is just a plain trapezoid. What is a triangle called that has the same side on two sides? Isosceles. Good job, Malachi. So just like you can have an isosceles triangle, you can have this thing called an isosceles trapezoid. That is when your legs are the same thing. Not your base, but your legs. Look at the trapezoid, though. Is this top base ever going to be the same as the bottom base? No. That's the difference. So your legs are the only two that can cause it to be an isosceles trapezoid. So if the legs are congruent, then it's isosceles. So when it's just a plain Jane trapezoid, I know that these two sides are going to be the same, or going to be 280, not the same, but they're going to add up to be 180. But the thing about isosceles is if it is an isosceles trapezoid, then SR is equal to TU, but this angle right here, angle R, is going to be congruent to angle U. Those are going to be equal. And S at the top is going to be equal to T. And that's stated right here. Okay, so let's pretend this is our green sheet for isosceles trapezoids. Let's label everything we know. I know that this is congruent to this, if it's isosceles. Let's label it. Let's say A, B, C, D. What angle is angle D going to be equal to? C. What about A?
B.
Good job. All right. We got to draw one of those X's in the middle. Was that y'all's class? Somebody's class was like, why are we always drawing X's in the middle of everything? When we're talking about their diagonals, so the diagonals of a trapezoid are always congruent. So AC is congruent to BD. All right, let's do two practice problems. Are these isosceles? Number one? No. If I don't know it, I can't assume it. All I know is that it's a trapezoid because there's one side of parallel angles. So, in a regular trapezoid, this and this have to add up to be 180. Thank you. So, 180, that's as far as I can zoom in. Do you need to trade seats with somebody? Okay. So, I know I'm not finding angle C, but this is a quadrilateral. So, everything inside of this quadrilateral is equal to how many degrees? 360. Good. So, this has to equal to 180 with this, so that's 55. Oh, okay. I'm sorry. We are going to assume this is isosceles. Sorry. I'm just going to tell you that. I'm assuming it is an isosceles trapezoid. So if this is 55, what does angle D have to be? 55. No. All right, number 2. Now, I do know that it's isosceles because that told me that 5 and 5. So these are the legs. What is this called right here? Base. What am I finding? I'm finding angle L. Well, that's 40, so this has to be 140 because they have to equal 180. So the measure of angle L is 140. All right, continuing on with the trapezoid. There's this thing called the mid-segment that can be drawn directly in the middle of a trapezoid. It breaks these two into 2 congruent parts and these 2 into 2 congruent parts. So if this side was 5, this side would be 5. If this is 5, then this is going to be 5. So to find the midpoint, we just find the average. I know there's this formula here, but when you're trying to find the midpoint of 2 things, you add them together and divide by 2. It's just finding the average. So right here, it's HJ, the midpoint. This is important. M is the midpoint and N is the midpoint. So whatever is right here, that's called the midpoint on each leg. Midpoint. Okay, so let's look at this trapezoid, HJKL, where M and N are midpoints. So if HJ is equal to 32 and LK is equal to 60, I want to find the average between them. I want to find what MN is. So to do that, I'm going to add 32 plus 60 and divide by 2. So MN is equal to 46. If you want to check, you don't have to. If you want to check, so if this is going to be 46, what's the difference between 60 and 46? 14. So let's put feet to it, okay? We're talking about feet. It has to be the same from the bottom base to the middle and to the middle to the top. So 16 plus, from here, there's a difference of 16 feet. And then from here to the top, there's also a difference of 16 feet. Why is that important? Because what if I told you that, let's see, is this one? Yeah, okay, let's just do number 4. Let me get a different color pen. Okay, number 4. HJ is 18. So I'm not using that anymore. HJ is 18. And MN is 28. So I can't find the average, can I? I can't find the average. But I know one base was 18. So what's the difference between top base to the midpoint, or the mid-segment? 10. So guess what the other part has to be? 10. So I went from 18 plus 10 is 28. So to find the bottom base, I'm going to do 28 plus 10. So they have to have the same difference between them. I can't find the average because I'm not finding the middle. I'm finding the bottom. So in order to do that, if you don't know the difference between 28 and 18, just plug it in your calculator. There's 10 units difference. So from 18 to 28, I add 10. From here to here, I have to add 10. So what's the bottom? 38. So LK is 38.